Discussing things a billion miles away, NASA researchers have accomplished a fairly exceptional feat. The test's telemetry regulation unit, part of the Flight Information Framework, was sending back a repeating pattern of code that couldn't be understood. From billions of miles away, at NASA's Jet Propulsion Laboratory in California, Mission Control on Earth received this information in binary code. A series of ones and zeros, essentially. It required time and some creative thinking for the researchers to decipher the spacecraft's confusing code. But once they did, they were able to identify the source of the issue. The test recorded the sound of interstellar space and carries a 70s-style phonograph record made of gold, intended to convey the sounds of Earth to any extraterrestrials who might discover Voyager someday. Its sister spacecraft, Voyager 2, has traveled an additional 12 billion miles from Earth. Both tests, launched weeks apart in 1977, have flown by Jupiter, Saturn, Uranus, and Neptune. The two spacecraft are now in interstellar space, the only space apparatus to operate beyond the heliosphere. They are humanity's sole extensions beyond the heliosphere's protective bubble, traveling alone in the vastness of space. NASA's Voyager 1 spacecraft, the farthest man-made object from Earth, continues to return usable data to ground control. This marks a historic achievement, as NASA has maintained communication with a spacecraft incredibly far away. Voyager 1 and Voyager 2 have been exploring our solar system for nearly 40 years, solving mysteries about the outer planets and discovering new moons. However, in a rare occurrence, Voyager 1 appears to be transmitting unusual messages from beyond the solar system, with no clear explanation. Is Voyager 1 finally breaking down after 45 years of interstellar travel? Or could there be another reason? Hello everyone, welcome to Imagine Space. In this video, we'll explore the incredible journey of the Voyager spacecraft so far, using new data that has scientists and researchers excited. Many of you simply watch and swipe, but don't forget to show your support by subscribing to our feed. The Voyager program consists of two spacecraft, Voyager 1 and Voyager 2. Voyager 2 was actually launched first, in August 1977, but Voyager 1 was sent on a faster trajectory when it launched about 2 weeks later, on September 5, 1977. As of January 2024, Voyager 1 is approximately 15 billion miles from our planet, making it the farthest spacecraft from Earth. It travels through space at a speed of about 38,000 miles per hour, 177 kilometers per second. Roughly the size of a subcompact car, the spacecraft weighs over 720 kilograms. They are the only two functioning spacecraft currently in interstellar space, beyond the Sun's influence. The Jet Propulsion Laboratory manages the Voyager spacecraft for NASA's Office of Space Science. When Voyager 1 launched on its mission to explore the outer planets of our solar system, no one could have predicted how significant it would still be 45 years later. Surpassing all expectations, the spacecraft has continued to operate and send data back to Earth throughout its journey. In August 2012, about 35 years after its launch, the spacecraft crossed into interstellar space. However, the official announcement of the discovery didn't come until 2013, after scientists had time to analyze the data sent back by Voyager 1. Voyager 1 was the second of the twin spacecraft to launch, but it was the first to fly past Jupiter and Saturn. For a generation, numerous news outlets and textbooks used the stunning photos sent back by Voyager 1. It also carries the Golden Record, a unique disc designed to transmit music and voices from Earth into space. The Voyager missions utilized a rare planetary alignment that occurs only once every 176 years. This alignment allowed the spacecraft to slingshot from one planet to another, maximizing the use of their limited fuel. NASA initially planned to launch 2 spacecraft past Neptune, Uranus, and Jupiter, as well as 2 more past Pluto, Saturn, and Jupiter. Although NASA seized this opportunity, shrinking budgets made the grand tour of the outer planets too expensive, leading to a scaled-down version of the project. The mission was downsized to a $250 million excursion to Saturn and Jupiter. While Explorer 1 focused on Jupiter and Saturn, Explorer 2 passed by Jupiter, Saturn, Uranus, and Neptune. Various scientific instruments were on board each spacecraft, including sensors, magnetometers, cameras, and bright and infrared spectrometers. The Explorer crafts were designed to survive for a few years but have far exceeded that goal with good luck and excellent budget management. Like the Pioneer spacecraft before them, the explorers observed Jupiter's moons and revealed them to be dynamic worlds of their own. Explorer 1 made several astounding discoveries about these natural satellites. For instance, images of Europa returned by Explorer 1 revealed a relatively smooth surface divided by lines, suggesting the presence of ice and possibly even an ocean beneath the surface. Explorer 1's closest approach to Jupiter occurred on March 5, 1979, when it came extremely close to the turbulent cloud tops. The probe was then set to proceed toward Saturn. It took researchers just 18 months by 1980 to capture up-close images of Saturn. The ringed planet turned out to be almost as fascinating as Jupiter. The F-ring, a tiny structure first discovered by NASA's Pioneer 11 mission the prior year, was one of Explorer 1's targets. 2 additional moons, Prometheus and Pandora, were discovered by the Explorer's high-resolution cameras. Their orbits help maintain the frozen material in the F-ring in a defined way. Explorer 1 also discovered Atlas, another ring called the G-ring, and captured images of several other Saturnian moons before it was finally time to head toward interstellar space. On February 14, 1990, Explorer 1 captured a multi-image planetary family portrait as it was leaving our planetary neighborhood for the edges of the solar system. It turned around for one last look at its home planet. Explorer 1 was about 6.4 billion kilometers away and roughly 32 degrees above the ecliptic plane when it captured an iconic image of Earth. Earth appeared as a tiny point of light, a crescent just 0.12 pixels in size, caught amidst scattered light rays. This image inspired the title of scientist Carl Sagan's book, Pale Blued, a vision of the human future in space, in which he wrote, "Look at that dot. It's here. That's home. That's us." The spacecraft's most thrilling moment may have been when it became the first of its kind to enter interstellar space. Explorer 1 left the heliosphere, the giant bubble of charged particles that the Sun blows around itself, in August 2012, plunging into interstellar space. On November 5, 2018, its twin Explorer 2 also passed through the heliosphere and entered interstellar space, placing both Explorer probes beyond our solar system. Explorer 1 has traveled farther than any other man-made object in history, setting records that may take decades to surpass. NASA plans to extend the historic Explorer project's missions for a few more years. However, after nearly 5 decades and billions of miles of cosmic travel, the pair of spacecraft are no longer the nimble mechanical marvels they were in 1977. Earlier this year, NASA delivered 2 software updates to Explorers 1 and 2. Repairs are not uncommon, but they now seem to primarily concern Explorer 1. Recently, NASA announced that a new issue had been identified. The engineering team is currently working on a way to give the record-breaking project a bit more life. However, Explorer 1's flight data system now seems to be stuck on auto-repeat. According to NASA, the interstellar Pioneer is still gathering and returning scientific data while receiving and executing orders from Earth. However, the attitude articulation and control system readouts no longer accurately reflect what is happening on board. This raises a key question. What exactly is happening with Explorer 1? The issue was discovered when the spacecraft's telecommunications unit began returning a pattern of ones and zeros repeatedly, as if stuck in a loop. These signals, unlike anything seen before, have left the scientific community both intrigued and, for some, unnerved. Some experts suggest the signals might not be of natural origin and could potentially indicate extraterrestrial involvement. The spacecraft can still receive and execute instructions from the mission team, but no scientific or engineering data is being returned to Earth due to a communications unit malfunction. Over the weekend, the Explorer team sent orders to the spacecraft to restart the flight data system, but no useful data has been received yet. Explorer 1 is so far away that it takes 22.5 hours for commands from Earth to reach it, and another 22.5 hours for a response. The technology on board the Explorers is outdated by today's standards. The memory on their computers is just 69.63 kilobytes, roughly enough to hold a standard JPEG file. After transmitting data to Earth, it must be deleted to make space for new observations. NASA specialists are currently working to identify the underlying cause of the issue before deciding the next steps. This process could take months to ensure the spacecraft's operations aren't unintentionally impacted. The Explorer team is carefully considering all potential outcomes before issuing further instructions to conserve energy and extend the missions. The aging twin Explorer probes have been gradually shutting off their instruments as they continue their vast exploration. Both spacecraft have experienced unexpected issues during their journeys, including a 7-month communication gap in 2020 when Explorer 2 lost contact with Earth. The mission team had to use a Hail Mary maneuver to re-establish communication after the spacecraft's antenna was accidentally misaligned. While the team hopes to restore the regular flow of data from Explorer 1, the mission's primary value lies in its longevity. The mission team has managed to maintain these record-breaking flights by developing innovative methods to conserve power. According to Suzanne Dodd, the project manager at NASA's Jet Propulsion Laboratory, the Explorers set new records daily with astonishing discoveries beyond our solar system. In approximately 40,000 years, Explorer 1 will pass by the star AC plus 793 in the constellation Ophiuchus, coming within 1.6 light-years, 9.3 trillion miles, of it. Thus, even as NASA works to extend the missions, issues are inevitable.